Today's show is sponsored by Equinix. We all utilize multiple cloud providers, and we know they aren't built to work well together. Things get a whole lot more complex when your hybrid infrastructure needs to connect with your multi-cloud portfolio. Equinix is the world's digital infrastructure company, providing on-demand infrastructure in over 25 metros, with hands-free provisioning and management, all connected to over 240 data centers and most major cloud providers. Equinix can help you deal with increasingly complex architectures, whether you want to run your favorite Kubernetes distribution or connect workloads between different cloud providers. To learn more, sign up at deploy.equinix.com and use the coupon code CLOUDCAST, CLOUDCAST, to get $500 in credits to get started today. That's deploy.equinix.com and use the coupon code CLOUDCAST and get those first $500 in credits today.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And it is Aaron for Cloud News. But before we jump in to Cloud News, just a reminder for everyone, coming up after the break, we actually have Addison Huddy, Senior Director of Product Management over at Confluent, to talk about the evolution of cloud-based Kafka platforms. So you definitely want to stick around for that. With that, we're going to jump straight into Cloud News because we actually have a good bit to cover this week. First of all, two interesting things with the EU and VMware and Broadcom. So first and probably most importantly, the Broadcom VMware deal wins EUC antitrust approval. Now, what's interesting about it, though, is the way in which they went about it or what they had to kind of concede. Marvell technology, and if you're not familiar with Marvell technology, fiber channel HBAs are the old adapter cards for fiber channel. They're the only competitor left to Broadcom. And as part of this deal, Broadcom granted Marvell pretty significant access to their standards, their cards, and some of the other information as well, because as the EU kind of put it, they're the last ones left, and this deal would potentially force them out of business, and so some concessions needed to be made specifically with this one company. So that's what kind of got the deal across the line and okayed everything over there. But that kind of leads to the second article. And this was by the Register, and a strategy document kind of leaked out that discussed Broadcom and VMware and all the ways, quite frankly, VMware wasn't working. And if you read through it, it's some things, if you've been around the industry, it is a little bit like, yeah, we kind of knew that already, but it's interesting to see this written down and leaked out, that, corporate strategy folks kind of agree and see this way. It's a pretty interesting read. It also goes on to kind of, a little bit of like, hey, Broadcom, this is how we're going to save VMware because this is all the ways in which they didn't succeed. I don't know how much I agree with all of that. And based off of how Broadcom has approached the markets in the past and acquisitions in the past, time will tell because, one of the things they say in here is like, oh, we'll probably need $1 billion R&D investment and another $1 to $2 billion in professional services. And that kind of goes against the playbook that we've seen in the past as well. So again, time will tell. We'll certainly watch this one closely as more information comes out. The next article is from the folks over at InfoQ, and we've talked about this one in the past. It is the DevOps and Cloud Trends Report. And there's a bunch of key takeaways. I would definitely recommend go read this. There's some really good stuff in here. Some things that are surprising and some things that are probably not a surprise at all. Of course, it mentions AI, ML, and large language models, LLMs. I feel like everything does these days. It goes on to mention, though, open telemetry. A really significant increase in open telemetry. It goes on to mention platform engineering and the trends that they're seeing in platform engineering. Another one that wasn't mentioned in the highlights that kind of caught my attention in reading through the article was both a mention of FinOps and talking about FinOps trends, and then also serverless. And what they're starting to see with serverless is it's less serverless as a standalone thing or a standalone architecture, and more of, hey, this is just a common choice and it's something that is there and it's another tool in the toolbox for folks to take advantage of. So definitely give that one a read. It is a little bit a longer article, but it is certainly worth it. And then lastly, again, definitely check these out. So there's 2 links here, both related to Cloudcast alum. First of all, Regine Skillern used to be at Intel, and we talked to her when she was actually at Intel. Well, she is now taken over as the CMO for AWS. The AWS CMO position has been vacant for probably a year, maybe even more than a year. Not a whole lot of fanfare was built up around this one, but really good to see her over there. We've had interactions with her in the past. She's fantastic, and I really look forward to what she's going to do. And hey, if nothing else, maybe we can make AWS reInvent a little more enjoyable going forward compared to what it's turned into here these last couple of years. And lastly, another Cloudcast alum, Richard Seroter. He has put together, and actually it's been kind of an oversight of ours probably for a while, puts together almost like a daily reading list, a daily link list of what he's absorbing and thinking about, and great subscription newsletter to add to your portfolio and your learning. Highly recommend it, and we've now subscribed and really have been enjoying it and learning a lot from Richard, and would love to also get him back on the podcast at some point. So with that, I'm going to close out Cloud News for this week. And again, coming up after the break, we have Addison Huddy, Senior Director of Product Management over at Confluent.
Today's episode of the Cloudcast is sponsored by Datadog. Bring speed and scale to your security organization. Datadog Cloud Security Platform delivers real-time threat detection and continuous configuration audits across applications, hosts, containers, and cloud infrastructure. Built on top of the observability platform, Datadog brings unprecedented integration between security and DevOps aligned to shared organizational goals. As a listener to the Cloudcast, you can sign up for a free 2-week trial to see for yourself how Datadog can elevate your cloud infrastructure security posture by visiting datadog.com/security-cloudcast. Sign up now and receive a free Datadog t-shirt. That's datadog.com/security-cloudcast. Introducing G-Core Managed Kubernetes, the ultimate solution for streamlined Kubernetes management. Experience support for bare metal nodes and a robust 99.9 uptime SLA at no extra cost. Easily provision Kubernetes clusters with a single click using our intuitive dashboard, API, or Terraform. Seamlessly integrate with G-Core external DNS and easily provision block volumes for your storage requirements. And of course, stay up to date with the latest Kubernetes versions. Plus, we have an exclusive offer for you. Click the link in the show notes and use the promo code CLOUDCAST and receive a £100 credit to try G-Core services today. Use the promo code CLOUDCAST and receive a $100 credit with G-Core services today. And we're back. And folks, if you've listened to the show for a while, there's been a number of topics that we've talked about in terms of how the cloud's evolved, how cloud services have evolved, how open source projects have both been delivered as software and eventually delivered as cloud services and so forth. And we've talked about both, the ones that have been terribly successful. We've talked about ones that, we've seen different things happen with them in terms of standardization. But we're always looking for, what's sort of coming next in this space. And, one of the people that we've had on the show previously, a guy named Dave Vellante, who's a very good friend of ours, has sort of coined this term super cloud over the years. And it's gotten various types of feedback, but one of the things that it's really focused on is, how do we start to build applications or cloud services that, take away, hopefully hide a bunch of the complexities of running cloud services? How do we not have to think about which cloud it's running in? How do we not have to think about, scaling and stuff that you had to think about really hard in the data center? What are some of the things that are starting to really kind of blur those lines or ultimately make it far, far easier for us? And today we're going to really dive into something that is, moving that ball forward, really kind of redefining an interesting space. And so really, really excited to have Addison Huddy, who is Senior Director of Product Management from Confluent. Addison, welcome to the show. Great to have you on.
Brian, thanks for having me.
We are going to dive into some really interesting stuff that Confluent's doing around kind of, I'm sort of calling it sort of next generation of Kafka. You guys probably have a specific name for it. But before we dive into all of that, give us a little bit of your background, a little bit of, both your background as well as the things that you're focused on today at Confluent.
Sure thing. So again, my name's Addison Huddy. I'm one of the product leaders at Confluent. I focus on Kafka. Been at the company almost 5 years, focused on Kafka that entire time. Before that, I was at a company called Pivotal. I've worked as an Apache committer in the past as a software engineer. And I consider myself a student of enterprise technology. So that's my big focus.
Yeah, you and I were talking a little bit before we turned on the mics about kind of the background of Kafka, Confluent's involvement with Kafka, and maybe more importantly, like this whole concept of event-based infrastructure, event-based streaming and applications. Why don't we start there? Give us a little bit of background, a little bit of a primer for anybody who may not be, terribly familiar with this space, because that will help us, I think, move into the broader conversation we want to have.
Sure thing. Yeah. So data streaming is a really powerful paradigm shift in how an organization works with their data. I remember seeing a talk by Jay Krebs. He's one of the founders and the CEO of the company, one of the co-creators of Apache Kafka. He gave a strange loop talk and he said, what if in an organization, every database change, click, account sign up, you name it, was captured as an event in a real-time stream of data made available to all the developers in the company as this real-time stream. I said, whoa, that's pretty amazing. Like if that was true, if that was possible, the handling of data within an organization would really change. New use cases would be opened up. You could do a lot more. You could create new customer experiences. And that's kind of what they did at LinkedIn. So Apache Kafka grew out of a project at LinkedIn. It was open source, donated to the Apache Foundation. And Confluent has been on kind of a mission to turn this into a platform, something that you can build on top of. And we have a variety of products. We have a software-based one and a cloud-based one. We're going to be talking a lot about our cloud product today. But we see ourselves as building something called a data streaming platform. I think we're not the only ones to call it this. And this, I think, is an emerging category, a data streaming platform. And I think there are 5 things that really define what a data streaming platform is. So first off, streams. You got to be able to publish, subscribe to this data, and the data needs to be stored. And I glossed over one thing that I think really changed the game with Kafka, because I think it gets too confused with a messaging system. So a messaging system, you're going to publish a message and subscribe to the message. And typically that is a write once, read once operation. Kafka said, okay, what if I take that same kind of pub sub model and I combine it with storage? So I can hold on to these events for a long period of time. So many people, many developers and applications can read that data. So you get this fan out. And more importantly, they can read it on their own time. So if I publish a message and you want to subscribe to it in real time, then another team kind of comes along and they start reading those. That means that everyone can operate at their own paces. You have a strong decoupling of both space and time of your data. And that's what really kind of changed the game with Kafka. Other systems have emulated, they've emulated this. But Kafka has evolved as the de facto standard for this, the actual API. Now back to Confluent, I have that streaming capability. I think, and that includes all the storage bits. I think you need a rich ecosystem of connectors, right? So you need to be able to connect this database or that SaaS system together and you need to stream it all in and out of your data stream platform. You need to be able to process the data in flight. So this is an interesting piece, is that as the data flows in, you're going to be able, you want to create aggregates on the data. You want to count data. You want to perform some operation on the data in flight. So as it flows downstream to other consumers of that data, they're getting what they need. You need to be able to govern and then share all this data as well. Those are kind of the last two pillars of a data streaming platform.
Yep.
And this is our mission. This is what we're up to at Confluent, is building this data streaming platform on top of Kafka. And recently, we've added Flink to our platform.
Yeah. Give me a sense, because like you mentioned, Kafka is not by any means the only sort of publish subscribe system out there. There have been event-based kind of queue systems and message systems. But give me an example. Like if somebody's, you're at a barbecue or something, and somebody says, "Hey, Addison, like, what's one of your customers do with your product? Like, what's an example of something that like somebody would go, oh yeah, I don't know how the technology works, but maybe like, oh, I've used an Uber and it seems like, they have all this real-time information that goes into the system. Like, give me just a sense of that a little bit."
Yeah, the use cases are really powerful, and they span industries. One of the kind of use cases that you hear often with Apache Kafka is Uber. I remember living in San Francisco when Uber showed up, and you could see the car moving across the map. You would get that ETA of where it is, and that's all powered by Kafka. You're streaming. The actual driver is streaming their location. The data is being processed in real time, and then it's being streamed to your phone. But the use cases go far beyond that. Some of my favorite use cases. Take a company like Instacart. When I place an order, there are a lot of teams that got to know about that order.
Right.
The store needs to get information. The billing team needs to get information. There's probably a whole fraud team that's going to run some checks, and their applications are going to be there. So that ability to stream that event into Kafka uses a term called topics, streams in, and all these teams are going to read that data. And, that powers that publish subscribe model. Expedia, that's another one. If I book a flight, I'm going to want to, a fraud team's going to check, a payments team's going to get hit. There's probably some type of, the actual booking needs to get made. There's probably other third-party services that I'm going to have to inform. And that ability to kind of orchestrate your operational system is quite powerful.
Yeah, no, it makes sense. Essentially, you guys give a whole lot of different teams a consistent view of the world at whatever time scale they want and so forth. And the actions they take on that aren't dictated by you. They can do all sorts of things. You give them, these topics, which are sort of, channels of flows of information, and then a common API that they can use. So, lots of powerful next steps can happen beyond that. Very cool. So, we sort of talked a little bit about, Kafka, Apache Kafka kind of spun out as a project out of LinkedIn. You mentioned Jay. Confluent is essentially sort of the leading developer and contributor to that project, but it's an open source project. And one of the things that you guys obviously did at some point, because the stuff you're doing is it's involved, it's complex, it needs to be at scale. You built Confluent Cloud back in 2017. Give us a sense. Obviously, we're going to talk about sort of the next generation of that, but I want to kind of have a reference and framework. What can Confluent Cloud do for a customer? What could they do, up until this new version came along?
Yeah, I think it's important to clarify a little bit of the Confluent Cloud journey and what we've been up to for the last 5 years. So in 2017, we embarked upon our journey to build a cloud product.
Yep.
And it was, I'm really glad we did it. It was a bold move. And, it served our customers really well with some of the decisions that we made. But the early days, I mean, no one had built a Kafka streaming service. And we knew we needed to, at the onset, we had a couple core principles that we wanted to hold. The first one is, we wanted to make sure that this wasn't just, an on-prem service running in the cloud with all the same complexity as an on-prem service. A lot of the value is getting rid of abstracting away a lot of the complexity of running a distributed system. And to do that, we knew we needed to build a SaaS product. We knew we needed to build something that, ran in our cloud, that customers would connect to, that we could be running at massive scale and with a really high degree of operational expertise. And, the first version of our cloud product, it was basically taking Apache Kafka. We had a Kubernetes operator that was quite mature at that point. And we put a control plane, a billing system on it, and we said, hey, here's our cloud product. And, it was it was the leading service at the time, but nowhere close to being what we considered a cloud native product. And we realized that pretty quickly.
Right.
And it was 5 years ago that we embarked upon this journey to completely reinvent what's underneath the hood of Confluent Cloud.
Yeah. Yeah. And that's, we probably could do an entire episode or a series of episodes in which we just sort of, talk to people who, have expertise in an open source project, or even just, hey, we have software and we want to turn it into a cloud service. Like, I don't think people sometimes grasp the enormous task of figuring out how to do that, because while you're an expert in that software or that, project, that technology, it doesn't necessarily inherently make you an expert, or you haven't necessarily built it in to be, a cloud service that runs 24/7 and hopefully doesn't require a whole bunch of humans to do things, and have to deal with, cloud regions and all sorts of stuff. And okay, so
yeah. I mean, you bring up a really good point there, and we Apache Kafka, it was designed to run where, you could walk down the hall and that's where the racks were. Right. And in a lot of cases, that's really good. Like, being able to walk down the hall and buy an amazing piece of hardware is awesome. Right. But, when you run into the cloud, there are pros and cons, right? There's no free lunch, and you need to design the system to take advantage of all the pros and minimize the cons. And that's what I think, cloud native engineering is all about. Yeah. And we needed to, I've done some back of the napkin math, and I've estimated that to kind of build this cloud native engine that we call Kora in our cloud, it was about 5 million people hours of work. That's just back of the napkin math, but and I can go into a lot of details on like exactly what we've done to do this.
Yeah. I want to dive into Kora. So I think, so we've sort of established, where did Confluent come from? Where did Kafka come from? What's Confluent's role in that? And you guys, like you said, 6-7 years ago had built a, let's call it version 1 of a cloud service that, like you said, was good, but wasn't, everybody sort of knew like, well, this isn't what a native thing would look like. This is the software running in the cloud that we run for you. Walk me through. So the new version that you guys have created is called Kora. There's links to it in the show notes. There's really good background information. Walk me through some of the kind of the thought process of like, okay, we're going to take on this challenge of making it, feel, operate, work, what feels like truly cloud native, and probably what you guys were trying to figure out what the next 5 years would look like. Like, kind of walk me through how you went about doing that. Because I can only imagine on one hand, like, you were probably like, cool, we're going to kind of get to start over and get rid of a lot of things that, weren't designed to work this way. But at the same time, you were running a business, you had people that were, like you said, you took up a ton of engineering time. Kind of walk me through how, the big things you were trying to do and maybe some of the trade-offs you had to think about in terms of, doing two things at once, maybe. Yeah.
One thing I'll start off by clarifying, we have this cloud native engine that we call Kora. Mm-hmm. Kora isn't necessarily new, right? We've basically given a name to the thing that we've been making for 5 years and our customers have been actively using. When we talk to customers, we break down our features into 3 buckets. We say Confluent Cloud is a data stream platform that's cloud native, complete, and available everywhere. And when I say cloud native, I get a lot of looks saying, "Okay, cool. What does that mean?"
Yeah.
And when I say, "Oh, we have this core engine. Here's this white paper all about it that describes its cloud native characteristics." Like, "Oh, okay, got it." So we've really given a name to the thing that our customers have been using for years, but it's not over. Like our core engine is still evolving, and there's still a whole bunch of things we got to do. But back, I would say early 2018, we realized, wow, there's something to this kind of Kafka SaaS product. It's growing really quickly, and we said, okay, what we have now doesn't necessarily take advantage of all the things that the CSPs offer. And we knew we needed something that was going to be, a multi-tenant first system. Like you look at all the best cloud native systems out there, S3, BigQuery, RDS, DynamoDB, like they run as these big giant multi-tenant systems. And that allows you to do all sorts of cool cost optimizations, increase your compute density and scale in a very elastic way if you do that. And you can also support, thousands and thousands of tenants with strong isolation if you do that. We knew we needed a system that was going to run across, all 3 major cloud providers, yep, across all the regions that they offer. I think we're in like 85 plus regions at this point. And we knew we needed something that was going to operate from like a small team at first and grow. Like we have, at this point, we're powering 30,000 plus clusters with a relatively small team to keep it cost effective. And that required a different design. One of the big components that we need to do is disaggregate the system. Kafka is a bit of a monolith, yep, because, there's only so many components I can ship in the jars that I give my customers, but we have the opportunity to disaggregate a lot of the core components, allowing us to change them and make them better over time. So, there is a distinct network compute, metadata and storage layer in our cloud, almost like this 4-layer cake that you can see. And we've been able to dramatically improve the performance of our product. Right now, for some workloads, we're up to 4x faster.
Wow.
I think we're going to be 10x faster by the end of the year. And all of this, I think, has allowed us to be much more cost effective for our customers. Higher compute density. We've been able to form really strong partnerships with the CSPs. We've created a service that is operating at massive scale. So you get this super elastic, really reliable, performant cost, and more importantly, compatible service. I'm a big believer in open protocols, proprietary implementations. Behind the scenes in our cloud, who cares what's actually going on? The thing that I consider sacrosanct is like, I'm offering up the open source Kafka API to my customers. And, if you want to go move to another service, you can do that without having to change any of your code. Right. But, my job is to offer you the best Kafka dial tone I possibly can.
Right. Yeah. And in theory, your customer shouldn't care how you run it, as long as, like you said, it's protocol compatible. You get the sort of SLA you want, and whatever other characteristics they may want. But it's not up to them care, like, do you do it with 10 people, 10,000 people? How it's distributed, all that sort of stuff is irrelevant to whether their application is going to work.
Yeah, that's right.
Yeah. So you mentioned, so that this has been this ongoing thing. Like you said, it took 4 or 5 years to build it, literally millions of man hours to build it. I'm curious, as you were rolling it out and you were talking to companies about this, were there questions initially more about like, what's going on behind the scenes? How does it work? Or could you have the conversation that was like, hey, you remember those like 7 or 8 things that you always thought were like blockers or were concerns? Like those all go away. Now you can start thinking about problems differently. Because I've heard that.
It's a great question.
I mentioned I mentioned in the open, like this concept that a friend of mine uses. He always uses sort of Snowflake as an example, where Snowflake will just say to you, like, look, we'll keep your data. Don't worry about where it is. Right. I have to imagine you had some of those eye-opening conversations with people that were like, oh, wow, this changes everything.
Yeah, I think the conversations come in a variety of forms. At first, they're saying, okay, well, how did you solve this problem? Like, how do you solve the data balancing problem? Because, in our Kafka cluster, we get all this skew, and then we explain about our self-balancing capabilities, and we talk about, how we are able to keep the individual broker latencies very low. And they're like, okay. And they're like, okay, how do you deal with infrastructure degradation? And, we've seen a lot of that in the cloud. And we're like, yep, that's totally a thing. We see all that too. And, we have thousands of health checks that are constantly running at all times on the cluster that are able to detect these things in real time. And we address them and remediate the problem. And they're like, okay, that sounds cool. And then we talk about our multi-tenancy capabilities. We talk about our networking capabilities. We talk about how you can replicate data between regions. And I think the customers that have been with us for a long time, they've realized like, whoa, this is a rock solid Kafka service. I don't have to worry about this anymore. And the conversation moves away from the infrastructure and it becomes one about the data. They're like, okay, how do I model my data? How do I think about schemas? And then they start thinking about, okay, cool. You have, Flink now. How can I make my data, richer as it's flowing through your system? How can I take my, you can apply the same type of like bronze, silver, gold pattern that you see a lot in the data and rest world to the data and streaming world. And we have customers doing that. So the conversation really does, with a SaaS service, it really does move away from the infrastructure and into the data, which I think is the more valuable conversations.
Yeah. Yeah. Well, and I can imagine, you highlighted well, for some of your longtime customers, they tell you about the problems they have. I can imagine for new customers, like it's probably almost a whole different conversation. Like you almost can bypass a bunch of that stuff because you're like, oh no, those problems just get taken care of. Like we gotcha. It's like a VIP type of service type of thing. They're just taken care of.
I mean, there's a lot of customers who, I don't have the pleasure of talking to because they just click a button, get a cluster, and off they go.
Right.
And they never think about it. And they, I'm always amazed at kind of seeing some of the new customers that are on our platform. It's like, oh, I didn't know they were a customer. That's awesome. Really cool. And they're just, have a pay-as-you-go account and, are scaling their service and happy with it.
Yeah. Kafka's really widely used. The API is really widely used. Was it challenging to rebuild essentially, or, restructure, redesign the majority of the system and yet keep the protocol intact? Or was that just sort of like, that's the one constant we're going to have, and then everything else can build around it? I have to imagine that feels like the first worry that everybody has if you say, hey, we have this sort of new thing.
Yeah. It definitely made it more challenging, for sure. I mean, if there would be a lot of things that I would change in the clients today that would make things, I think, easier. But, we are members of the Apache community. We're continuing to contribute it as the likes of Uber and AWS and Red Hat, and it's a massive ecosystem. And I think it's amazing that we get to be participants in this larger community. And I'm a big believer again in open protocols, proprietary implementations, and I think that yes, it's harder, right? It's like, wow, okay, we could make that protocol change, or we have to do it on the server, or maybe we have to submit a Kafka improvement proposal and have this evolve. But I think that's a healthy thing. I think that is more of a feature than a bug.
Yep.
And we're going to continue contributing to the open source and evolving it and being active participants.
Yeah, no, that's great. That's great. You mentioned it at the top of the show. You'd previously been at Pivotal. A number of us have worked on various big open source projects. Pivotal obviously with Cloud Foundry, others with Kubernetes and all. I'm curious in this. I don't expect you to speak on behalf of other things, but kind of knowing what you know now, having taken Kafka as a community project, it was designed to be, like you said, software that you could walk down the hall and plug it into a server. Do you think as things like Kora and how you guys did this become more visible, like we'll start seeing more companies go, I have to build a cloud native experience like this? Is it, I don't know, what's your take on, will this be kind of a lighthouse, or other people going, oh, we're really going to have to do this because this is going to be the new expectation from companies?
100%. Like there's an expectation already in the market of how a cloud native service should behave. Mm-hmm. And I'm really glad that, we made the decisions early on to build a serverless offering, to build one that, tried to abstract away the complexity. And that allowed us to change the infrastructure behind the scenes as we evolved. Yeah. And will continue to evolve. If we had gone down the path of, having like a BYOA offering, I don't think we would have been able to do that. And, we took lessons from, Databricks. Like I believe the Databricks CEO was quoted as saying, the biggest mistake he made as an entrepreneur was creating like a bring your own account offering. And we took that lesson, right? We saw that quote and we said, okay, we get it. Just because it's too complex for the users and you can't provide that cloud native experience. So the fact that we started out with a serverless offering from the get-go has allowed us to evolve our offering to provide that level of simplicity to our customers, because if you have something where, you're puppeteering into somebody else's environment or something like that, that shared responsibility model just doesn't work, right? When it hits the fan, whose responsibility is it to get paged? Like, whose job is it to go and hit the run book? Whose job is it to have written the health check that remediates the problem, right? And in a SaaS offering, it's clear as day. And I'll give you one story that I think was kind of funny, and I've never had this happen before in my career. Is I mentioned that behind the scenes, we're constantly evolving Kora. Like it's getting better every day.
Sure.
And the fact that there are no versions, there are no upgrades. It's just constantly evolving behind the scenes and getting better. We've had some funny experiences, and there was one release that we did where this one customer's workload got 8 times faster, like overnight. Like we updated the cluster, and I woke up to a support ticket, and this customer was saying like, "Hey, I think there's a bug," and the support ticket. Someone says, no, we made a performance improvement, that all systems are normal. And the ticket just says, awesome, great, thanks, have a great day. And that's where it ended. And I think that's only possible when you have, that's what's possible with SaaS.
Yeah. No, it's Yeah, again, I keep coming back to it's the transition period is really challenging because we've talked a little bit, like you have certain customer expectations, you have those concerns about who has ownership of things, who has responsibility for things, and I think you highlighted two really important things that are really hard to do. One of them is to be confident in, like you said, that idea of, kind of open protocols with, proprietary implementations or just, unique implementations. Like there are people who will get scared off, companies who will get scared off, product managers who will get scared off of that to say, well, somebody's going to claim that, if it's intended to be open, everything has to be open. And again, like you could get into arguments about that could skew your decisions to do stuff. And then, like you said, to have a very clear model of like, these are your responsibilities as a customer, these are our responsibilities as a provider, and provide enough value around that to where people go, okay, I'm going to live with whatever constraints that might have because the value on top of it is so much better. And those are really hard trade-offs to make, especially when you're in the early stages and you think like, God, I want to do everything for everybody. But it's commendable that you've reached that point. You sort of lived through it, and now you're at a point where, like you said, you can have conversations with customers where things become just like you're just opening new doors, which is super powerful.
That's a really good summary. Yeah.
I'm curious, and I'll ask you one last question. And I know you and I talked. You have some hard stops, which I totally appreciate. We talked a little bit at the beginning about an Uber or an Expedia or somebody. Have you seen yet somebody come to you with a use case or an idea that if they had come to you 3 or 4 years ago with sort of pre-Kora Apache, that you would have been like, oh, that's not possible. But they've come to you now and they've been like, hey, we want to do this. And you're like, oh, that's possible. Like any examples of those that you can think of that you can share?
Yeah, that some of the scale numbers now are really mind blowing. I can't go into all the details, sure, but there was recently a massive sporting event, like one that I couldn't. It was something I didn't know a lot about, and I've since like really, really fallen in love with. Mm-hmm. And it was at a scale that I couldn't appreciate. And we have clusters today that can go up to, like, just click a button and you can get this cluster. They'll go up to 20 gigabytes of throughput. Just you can go click a button and you'll get this cluster. Yeah. And that's what happened. And it was awesome. and if someone came to us with that level of load and those requirements, I would have been like, yeah, okay, no. Right. But now that's kind of we heard the requirements, we heard the use case, and we're like, yeah, no problem.
Yeah, that's got to be cool. It's got to be one of those cool moments as a product manager, because you deal with a lot of grief, but yeah, when the thing turns out, that's pretty awesome. I'm going to wrap it up with that. I think that's a good place to sort of wrap it up. If people are listening to this, they're in the Kafka space, they're building applications, they're thinking about this sort of stuff. What are good ways to, either, engage with Kora, just like you said, click a button and get it, or if they want to maybe engage with your team or around the Confluent team, what are some of the best ways to do that, or even just to get started?
Yeah. So I'll give you 2 links. If you go to Confluent.io or Confluent Cloud, I've talked a lot about Kora and a cloud native system and what like a SaaS infrastructure looks like. I think picture's worth 1,000 words. You can click a button, sign up real quick, click a button, and you can get hands-on with Confluent Cloud, and be knowing that you're getting the 10x core engine when you do that. If you're pretty new to data streaming, I highly recommend checking out developer.confluent.io. Amazing resources on there that go from writing your first application to June Rao, one of our other co-founders doing a deep dive into Kafka internals. Those are both, amazing video series on there. So developer.confluent.io and confluent.cloud are two really great resources.
Yeah, good stuff. We'll get both those in the show notes for everybody. Easy to find, easy to click through. So, Addison, thank you so much for the time today. Not only kind of educating us on where the data streaming world's going, but also just kind of some of the behind the scenes of what it takes to build some of these truly cloud native types of services. So thank you so much for the time. Folks, with that, I'm going to wrap it up. I want to thank, on behalf of Aaron and myself, thank Addison for his time. Thank you all for listening. Thanks for telling a friend. Thanks for helping us grow the community. And with that, I'm going to wrap it up. We'll talk to you next week.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.